So what is network security? Let's talk about this a little philosophically. It's a very wide area that it covers, and it overlaps with other kinds of securities that you might have heard about. But what we are going to see in this course is anything to do with network security. So basically, it deals with securing data that is stored or it flows through a network, security of network devices, and the endpoints. So the endpoints could be host and server, two hosts, or two users of the network communicating, sending emails or other files, or you accessing information from web servers, or two devices communicating. So we are dealing with all that is connected to networks. And since the internet is the largest network, we'll fall back upon the internet to have our examples. Now, you might have heard about cybersecurity and IT security. How are these different from network security? Cybersecurity is to do with systems or security of systems that are connected with the internet or the cyberspace. So internet is a cyberspace, and when you connect to it, you are part of the cyberspace. And then you are open to attacks from other people on the internet. So cybersecurity is more focused on the security from attacks on the internet. But in network security also we are concerned with security of attacks on the internet because internet is a network. That way they overlap. IT security is a term more commonly used in businesses, and it basically consists of security of all the IT infrastructure used by the business, the network within the organization used by the business. If they are connected to the internet, all the threats that are coming from the internet, the data belonging to that organization, and security of the process data, that is information. So you'll see that they all kind of overlap, and sometimes we're talking of the same things, but they're used in a slightly different context as we have just seen. We will talk about network security in this course. Now, network security, what is it? Okay, let me go back a little bit and delve upon this. Let us dwell upon this issue. What is the security that we expect a network to have? So let's say two persons are communicating with each other. What do they expect from the network? One, they should be able to send their messages across confidentially. So this confidentiality comes in many kinds of communication. And we are here concerned with people communicating, and they want confidentiality in their communication. So it could be like during wartime, the communication has to be confidential because it may be a spy sending information to the headquarters, or agencies in defense forces talking to each other, or any kind of communication dealing with war. We are not going to take war example here. The other example could be of two persons in a relationship, say Alice and Bob, who are trying to communicate confidentially and securely, and they exchange messages. This is kind of a little more interesting, and we'll take these examples quite often. So what do they expect? They expect that they should be able to confidentially send their data to the receiver. So Alice could be a sender sending to Bob the receiver. Bob could be a sender sending to Alice the receiver. And they want confidentiality because of the nature of the messages. The other thing they want is the data should not be tampered with. So the data should not be changed, otherwise the meaning of the message that is going might change. The data should not be stolen, message should not be pilfered. No one else should be able to corrupt that message. The other thing that you might need is to ensure that if you are Alice, that there is Bob at the other end, no one else. Somehow you want to authenticate the person. You want to make sure that you're talking to the right person. So these are the and you also want safety of your system, that no viruses should come on your system and disrupt the work that you're doing. These are the basic things that one needs. Now see the NIST, that is the organization that makes standards for network security for the US, especially the government agencies, but then others also follow this, gave a model in late 70s, 77, which described what security looks like. This is also called CIA triad. The abbreviation CIA stands for confidentiality, integrity, and availability. So this is what we need. They said this is the model that we should use for any secure communication arrangement. The information that is being sent should be confidential. The integrity of data that is flowing through the network or stored somewhere should be maintained. That means no one should be able to intrude and corrupt the data, tamper with it, that is change it, or steal it, anyway compromise the data. And this network should be available to the authorized users of the network. They should not be disallowed to use the network. The network should be available. So a secure system should have these three properties. But with changing times, the nature of work, businesses, interactions, they have also changed. The technologies have changed, and now the requirements have changed. And we have to add more vertices to what was earlier the triad. It now becomes some kind of a star with 6 points. What has been added is the authentication, authorization, and non-repudiation. So along with CIA, we also need to authenticate, as I have just said. We also need to authorize the users and see that only the authorized users are able to connect to the network and use it. A very important thing these days is non-repudiation. Because of the financial dealings or e-commerce, this has become very important. People should not be able to deny the actions that they take. For example, if you send an order for something, you should not later be able to say that, no, you have not ordered this thing. It was some kind of a mistake or some kind of an attack. It's very important for many transactions that people should not be able to deny the actions that they have taken. So all this constitutes a secure system. This is why we say that the face of security, the way the security was conceived earlier and the way it is interpreted now, is a little different. Now let's see the elements of security again quickly. The CIA, that's the older one, consisted of confidentiality. Only the concerned party should be able to understand the message. So here comes the element of encryption. So you want to change the message or encrypt it in such a way that only the receiver is able to decrypt it. And if the intruder on the way looks at this, they should not be able to easily make out what the message is. So the better the scheme, the more confidentiality you get, but of course more complex to implement it. Integrity, message should not be changed, mutilated, or corrupted. So think in terms of, if you go away from Alice and Bob example, think in terms of the patients who are on medical devices, communicating with the servers, or the doctors modifying the settings of their devices. So they have a pacemaker or they have a respirator, and there are certain settings that are required for that patient. But if there is an attacker who's able to change the settings, well, you have a problem. If the doctor is sending a communication to the patient's devices and the intruder is able to change it, then the patient's life is in danger. So we have very serious communications going on, and therefore integrity is a very important requirement of secure communication. So you have seen checksum, how checksum is used to detect problems with data. You've also seen CRC, cyclic redundancy codes. We have not seen, but we'll see now, cryptographic hash functions. These are some of the techniques used to ensure the integrity of data. Availability is saying that it's always available to authorized users. Of course, leave aside the maintenance downtimes and so on. But if you are an authorized user, you should be able to use the service and should be able to access the network. So this involves the infrastructure security and data security. So your network should not be attacked and the devices should be secure and they should not be unavailable to you. The data, of course, that is stored and flows in the network should be secure. There should be redundant devices so that one router fails, the whole network should not be brought down. Then if there are problems in the network, the network should be able to recover from those problems. So all these are design things that are built into the network when the network is designed. So the design should be keeping in view the security angle for the users. So these were the old things that were there already in the security model. Now the new things that have been added, that's AAN authentication, or confirming the identity of the communicating parties. So we'll see how digital certificates are used to do that. And then, of course, authorization. Only authorized users should be able to access the network, and we have something called access control list to allow only the authorized people to access the network. Non-repudiation, that is denying, so preventing people from denying what they have done. So we have digital signatures using the public key infrastructure. We'll look at these things also, why they are required and how they are used. So these are the essential elements of security that you have to keep in mind. Now let's see the security actors, the sender, receiver, threat actors, and so on. So the sender and receiver are Alice and Bob respectively. Usually the Alice is the sender and Bob is the receiver, but actually in actual communication both are senders and both are receivers. So what we say in terms of Alice sending to Bob, it could be Bob sending to Alice. There's a third person here called Trudy, who's the intruder, who's trying to decipher the message. So as I said before, we are talking about communication between two persons, Alice and Bob, who are in a relationship. They are trying to evolve their relationship. And Trudy is the third party who might have crush over Bob and trying to make out what's going on between them. So whereas here it's a simple, daily life example, but this could be, the sender could be a client and the receiver could be a bank. It could be communication between a host and a DHCP server. It could be between a host and a DNS server, where you're trying to access IP addresses of websites, and this could be attacked and you may be diverted to a wrong website. You may have buyer and retailer in the e-commerce case. And there could be attackers like Trudy in all of these. Who are these attackers in the real world? These attackers could be script kiddies who are just trying to learn the ropes and they are trying to attack networks just for the fun of it. Then there are individuals who could be something like mercenaries, doing it for money for themselves or for someone else. So there could be organized crime involving network attacks, or it could be nation state. The actors, the threat actors could be nation state doing for political gains, to wage a war against, a cyber war against other countries. So they use something called advanced persistent threat, or APTs. So attackers come in many forms. Here we have an attacker whose sole aim is to decipher messages between the sender and the receiver, and to make out what they're saying to each other. So what can Trudy do? Simple things are eavesdropping, or somehow reading the message, intercepting the message, and trying to make out what is being said, or tamper with the message, alter it, so that the correct meaning is not conveyed. With the information that Trudy can get by doing this, she can launch a more serious attack, and consider Trudy as attacker in other systems as well. So if the attacker can get password or social security details from you, then there could be an identity theft, or if it's a password to your bank account, you could face financial problems. The attacker could hijack the session, and so Trudy can hijack the session, for instance, and talk to the Bob as if she was Alice, and say things that will spoil the relationship between Alice and Bob. Or the attacker could launch a DOS attack, a denial of service attack, so that she somehow makes sure that the Bob system is so busy that the sender or Alice is not able to communicate with Bob. So there are many ways that the attacker could attack the system and spoil the game between the sender and the receiver. So these are the security actors involved in the system. We'll talk about them again and again. So what all can Trudy do? We saw some of these things. Tampering was one, and I gave an example of tampering data in patient devices. So Trudy could be some other organization trying to encash attacks on hospitals, for instance, for money. They're trying to do attacks for money, and they threaten to put patients in danger by altering settings of their pacemakers or respirators or other devices, putting their lives at risk so the hospitals pay up. So ransomware is another example of tampering with the system, or taking over the system, or locking the files and so on, so the data is not usable. Spoofing is a very common method used for attacking. So men in the middle or women in the middle attacks, where the person who is trying to attack poses as a legitimate person, and then can gain access to the information that is passing on from sender to the receiver. ARP spoofing is one. We have seen ARP is the address resolution protocol that gives, so we use that when you need a MAC address, and you already have an IP address. So MAC address of the receiver, or the other end, or the destination. So an attacker can poison ARP tables, or can spoof ARPs, take the IP address of a legitimate party, put its own MAC address, so that when the sender asks for the MAC address for this IP address, the MAC address of the attacker goes, and the communication now is between the sender and the attacker. Then attacker can gain access to information then that the attacker shouldn't have. Or DNS spoofing or DNS cache poisoning is by, DNS is what gives you the IP addresses of the websites. So they're trying to resolve the website IP addresses. It's the DNS that you have to go to. So a client, an HTTP client, would access DNS to get the IP address of the server. And if you change that, you may divert communication from that website to your system by changing the IP address in the DNS. This is what happened to Malaysian Airlines in 2015. See the picture on the right. So when users was trying to access Malaysian Airlines website, they were getting this message: 404 plane not found. This was coming from a server of the attacker. And what was done was the IP address was changed to the attacker's server's IP address. So whenever someone was accessing Malaysian Airlines, it was going to the attacker's server. So CADA, or Center for Advanced Internet Analysis, is they prepare statistics of these kind of attacks. They keep track of this, and according to them, on an average, there are 30,000 DNS spoofs per day, which is a large number. So if they are not caught and prevented, there would be havoc all around the internet. Denial of service is something very serious on the network. You might have heard about it. Denial of service, or a more complex variant, distributed denial of service, also known as SMRF. Now, what could happen generally in denial of service? A resource on the network could be a server or a host or a network device is inundated with so much work that keeps busy doing that useless work, and the actual users are not able to use that resource. So they are denied the service. So let's say attacker doesn't want you to access some web server. The attacker can attack the web server, make it busy, and then when you try to access that website, you don't get anything because the server is too busy. One way to launch a distributed denial of service or SMRF attack is to send ICMP from a spoofed IP address. So an attacker spoofs an IP address of a server. Using that source IP address, it sends ICMP messages to a number of computers on the network. And when a computer or a host receives an ICMP message, it sends a response. So when hundreds of computers receive ICMP, they all send responses to this IP address, which the attacker has given as a source address. And when this server receives so many responses, it gets overloaded with that. And then it's not able to do any useful work. Or a SYN attack. A SYN attack would be, you know what a SYN is. In TCP connection setting, you have a three-way handshake. So a client sends a SYN signal to the server. The server responds with reserving the buffer space and defining those variables, and then it waits for the next part of the communication, and then nothing happens. It sends acknowledgement, but nothing happens from the client. So the attacker can send a lot of requests from different computers, and then the server just wastes resources in this useless communication. So ping of death is similar. Large number of pings can be sent to keep the server from doing any useful work. The largest DDoS attack that has happened so far, I have not updated this for the last 6 months, but I'm sure that this must still be the largest, was 1.7 terabits per second of data being sent to a customer of Arbor Networks. So the system was so overloaded that was not able to do anything else. This was in 2018. Before this, the largest was 1.35 terabits per second of data going to GitHub and causing denial of service attack. So this keeps happening very frequently, more frequently than we would like on the internet, and we need to devise systems that makes internet secure against these kinds of attacks. What else can the attacker or Trudy do? So Trudy can gather information, or in other words, we say active reconnaissance. So you can scan ports, for instance, use Nmap or something, gather information about a host or a server to later launch a bigger attack. It could be phishing attack as well, SQL injection. That's a piece of software that you inject to get unauthorized access to databases. And then you can launch exploit attacks. So, Trudy can gather information, do all this. Then repudiation would be like saying that changing files and then claiming that you have not changed it, or doing transactions and denying them. So in cases where you have to prove who has done the transaction, digital signatures could be used. Elevation of privileges is something where the attacker assumes the identity of a privileged user. You don't have those privileges, but then you steal the identity, elevate your privilege, and then do things that you're not supposed to